Okay, so we have time for questions, and if people want to go to the microphones to ask we had different points of view from many of these. So while somebody's going to go ask a question, I'll ask David a question. Do you find, like many industries, you are now very global and you're doing R&D in other countries, and you talked about your European experience that took three years. Are you, how are you seeing some other countries more forward-looking in how they're looking at centers versus what the U.S. is doing? Look at ideas.
Yeah, I think we see differences, certainly in terms of focus. I mean, as far as I know, we're the first or one of the first foreign-owned dedicated R&D enterprises in China. Been there since '97, worked with Tsinghua for probably 20 years, for example. One of the things that I saw that was interesting is when there was a lot of push in the US on additive manufacturing. And we'd start talking with universities and they showed us a machine or something they were doing that was interesting in that scale. We would go to Germany, a place like Aachen, and find 3 buildings full of advanced manufacturing technology, additive machines, working with industry, and things of that fashion. So I think what we find is in different spheres and different areas, some parts of the world are ahead of us even in terms of connecting that to the application, having that sort of end-to-end part. Because if you think about basic research to the application, I think for too long we've segmented it and made artificial barriers between basic, applied, and the development. And so sometimes when people think, well, I want to have more things pop out and have impact on the market, they simply think about funding more things at later stage, as opposed to thinking about the continuity where the gaps are and actually taking those ends and bringing them together. So if you think about the line, it's wrapping it around together. And so what I've seen is, where you have the opportunity to put folks on that whole spectrum together in one place and foster that kind of collaboration, it happens much more effectively and quickly. I've also seen just the rest of the world's trying to copy the US, and sometimes they're trying to copy things that we've done that make it hard. I found a university overseas where the whole university graduated 6 PhD students a year. I have colleagues at universities who have more than that, individual faculty. Yet they set up and hired 3 people for a tech transfer office. And I said, look, you don't have this, the pool of things to license. You've got it backwards. Yet they're all trying to be like Silicon Valley, all trying to be like the US. And I think that's a part that we've also seen a lot of interesting changes around the globe as people seek to copy the US.
Good question.
Andreas Kingelaris, University of Illinois. I have 2 questions, and I would like to start with Tom Siebel. And you highlighted, Tom, a very interesting angle, and that is how philanthropy and foundations can play a significant role in energizing innovation through universities, through the right cultivation of talent. How do you see this kind of role becoming more prevalent today as more young entrepreneurs try to find ways in which their interests in terms of innovation can take advantage of the academic ecosystem and the federal funding agencies?
I think one of the very interesting trends, in this area that I'm not certain, but might have begun at Stanford, and now has proliferated to Berkeley and Yale. Well, and maybe it began at MIT. I don't know. But it's this proliferation of these multidisciplinary centers for design. They call it the D School at Stanford, the Jacob School at UC Berkeley, where we're bringing together fine arts, performing arts, liberal arts, humanities, very frequently run by mechanical engineering, doing amazingly creative work, in product, ideation, and some of these are virtual products, but ideation and design. And now we're seeing this at, Yale, University of Illinois. It's happening everywhere. And this is very clearly designed to be multidisciplinary, but it's also the engineering organizations, most usually ME, is bringing an engineering rigor to the process. And so I think this is a wonderfully exciting development. And it seems to be, there are 1,000 points of light now springing up around, well, certainly North America. And I think this is going to be one of the exciting trends in that area. Shanker. Oh, I'm sorry. Oh, Andreas.
I had a second question for Dr. Sullivan, and I want to come back to the national laboratories. Tremendous national resource, always playing a low-key role by design, perhaps, or by behavior. They have not been highlighted, I believe, among the public at the level they need to be. You asked us, and we know very well who you are, because many of our graduates come and work for you, and vice versa. We depend on collaborations with you. But I think it is, especially now, it is very important for the national labs to step up and openly talk to the country about the role, the impact they have. And I think one of the things we need to be doing is partnering more aggressively in broadcasting that impact, because I will tell you, many of our graduates would rather go and work in the private sector than go to the national laboratories. And there are sometimes perceptions that get in the way. Sometimes there are realities in terms of financial rewards and so on. But I think a way in which we can come together, the federally funded institutions with the national labs, we are in the same business, many of us depend on taxpayers' money. I think that will benefit everybody.
I absolutely agree. I do think that our history is part of the reason that perhaps we were more low key, but that history has changed. Certainly for the Office of Science Labs, that's an old tape that people might be playing. Our lab director, just to finish the University of Illinois theme, is a University of Illinois grad. He's PhD in applied mathematics there, and computer science. He would kill me if I didn't say that part. But he is definitely trying to get out and be more aggressive in telling the story, not just to our local community who know us very well, but the lab directors are actually having their meeting right now here in DC, and they get together and they're trying to figure out how do we tell that story, because the challenge that we have is well, at my lab, I probably shouldn't say this, but they know me. I have a saying, personally, this is only my saying, this is not speaking for anybody else, which is every time something goes wrong at Los Alamos, I get more training. But every time something goes wrong at Los Alamos, that's when people hear about the national labs, right? When something goes wrong. They very, very rarely hear about the good things that we're doing for the country, and some of the things we can't tell them, right? And that's the nature of the work that some of the work that we do is a tremendous amount of work that we do is in non-proliferation detection. And a lot of it we can't talk about other than saying those words. So that's a challenge that we have. But I do agree with you that getting that story out is an important piece. But I think that your idea of partnering together to get that story out is better, because I would rather have somebody else tell my story than and have me highlight your story. That I think is I feel like that's a more honest approach. I mean, I can go out and say how great we are, and we are great. Don't get me wrong. But that's me saying it. And so somebody else saying that the national labs are doing great work for the country is a more profound message that comes out. And yes, we do want to hire people. We have, by the way, if anybody has a nuclear engineering department, please come talk to me. But I agree that getting those stories out, but also getting the stories out of the university research. I think that we're not, I mean, those stories aren't as well known either. And in the general public. I think that all of these things, the economic driver that the universities and the national labs create, those stories aren't well known. And then people just say, oh, we're just wasting the money sending it off to do research, and then they pick out some title of a study that they don't understand, and they say, why is the NSF funding this stupid project on plant stress? And they think it's somebody's going to go yell at a plant versus learning how to grow plants in drought environments. So these kinds of things are a challenge with public perception, and let's figure out how to tell each other's stories to our mutual advantage.
It's a question for both Tom and David. You know, I was struck in your presentation also for something you said, David. You know, in the foundation, it seems to me that you invest in sort of the riskiest part of the research pipeline, almost even before even before the feds and or even peer review is willing to invest in the research. And so the question is, in these public-private partnerships, what is your sense, and maybe I'm walking on thin ice here, traditionally the role of the federal government was to take on the highest risk in the investment. But is it your perception now that because we, the people in our peer review, have sort of stunted that, we do need sort of philanthropy to sort of assume and foundations to assume sort of the burden of the riskiest research?
Hopefully not. One of the things I do is also, speak on the Hill about the importance of R&D investment and where we need to be as a country, and that's key. But along the lines of what you said, I think certainly there's a key role, and for us, I would say there are two parts. On the foundation and sort of philanthropic part, we do that because we believe STEM and things of that fashion are important. So whatever we can do that promotes that, that's that investment. There's the R&D investment of the corporation where we're looking at what's our responsibility to our shareholders. And there it's not to create knowledge for its own sake for the public good. If that's a secondary benefit, that's great. But there it's about how do we develop technologies that will enable and create a competitive advantage in the market. And sometimes in some of those spaces, we find there's no fundamental research being done because it's not the hot area. So, with all the focus on info and bio, there's a lot of things missing in the physical sciences world that relate to the propulsion where, the same engine can be sold 50 years later in materials and things of that fashion. And so we find sometimes in some of those spaces, the modeling of two-phase flows. We're doing things as fundamental as any university, doing things that people said could not be done. But it's more, that's the driver in how we think about it, where there's a fundamental piece without which you can't do the latter stages and other people aren't focused on it. Then we'll do that and we'll dig as deep as anyone. And I think that's where also we collaborate with our colleagues at universities because we're seeking the robust answer. The rigorous theory needs to be provided in the academic community, but we need to do that side by side.
Just a quick comment on philanthropy, which is, in philanthropy is, primarily an American phenomenon, okay? And it was begun, there's kind of two ideas. There's Carnegie's idea and Rockefeller's idea, and this is where it began. But, I am a huge critic of the way philanthropy is conducted in the United States. I mean, we have organizations, some of which are run, by very good friends of mine, okay, massive organizations that have staffs of hundreds of people evaluating proposal requests. And look at their annual reports. They're granting, $10,000 at a time to the Women's Quilting Society of Armonk, New York, okay? I mean, this is insane. Okay, and some of these, a good friend of mine runs the Hewlett Foundation, or you look at the Ford Foundation. Okay, and what I mean, with the resources they have to focus these resources on something important. How about cancer? How about the environment? How about energy? How about sustainable food? I mean, and to dissipate the resources with these massive staffs, $5,000 to $20,000 at a time, I think is, I completely disagree with that school. I think that philanthropy should be, there's a place for it. There's a place for it in science. They can make change happen, but they should be making big bets on smart people and important projects.
Yes, I'm Alok Sinha
Now
from
really get
Penn State University.
Wait. The emails are going to fly this afternoon, believe me. Okay.
Okay. Yeah, my question is, when it comes to new technology, the interaction between university and industry seems pretty clear. But when it comes to technology which has been there for a while, probably, for example, jet engine, etc. Now, when university people do research, they don't have access to all the knowledge base which is already there. So then can there be anything done to enhance that interaction so that university can also contribute more significantly in those areas? I guess question goes to David.
No, I think it's a good question. I mean, and that's sort of part of my remarks earlier. The key for moving things forward is about collaboration. but often there are lots of barriers to that. I mean, I found, for example, some of the most interesting things are where you develop things together that you couldn't apart, where asking the right question actually gives up IP. And so, creating a space where that can happen is key. So I would say it has to be where you have things of scale that are meaningful, so that then you give the reason to work through all those barriers. So, for example, our work with Stanford Center for Turbulence Research, this is the one that's been around for 3 decades and what they do in turbulence modeling. Pratt & Whitney actually gave them the geometric lines of an engine so that they could do on one of their DOE programs a calculation and a computation of flow in an engine from end to end. So this was over a decade ago. I mean, a really tough scientific problem, and you had that. And so I think it often is that, and then I think the other part is where you can find ways, and that's why I was saying that earlier, to have people working side by side. The problem a lot of times we find is the funding vehicles are like diodes. They're unidirectional. And so when you actually want to have people collaborate, there are barriers to it because they say, no, that's not the role. Even CRADAs only work one way. Jean-Louis' example earlier, I actually offered to pay for one of my folks full-time to sit at a national lab, and the lab director loved it, said, great idea. The lawyer said, anything that person invents is owned by the lab. And I thought, we're trying to promote collaboration. We all think it's a wonderful idea. I'll write the whole check. And there are barriers like that. So I think that's key. So the other part that I found is if we can work together on government-funded programs, what's nice about government-funded is there's no debate about all the terms and conditions. It makes it really easy to get started. And so what we found is our collaboration with national labs, with universities, often can start very nicely on ARPA-E, DARPA, NSF, AFOSR type programs. And then you start building the joint interests, commonality, and then you can build on that.
Minutes left and 2 questions, so each of you yes, and I know that Jean-Luc got, I think, stimulated by Tom's comment.
Yeah, and I would like to, it's not really a question, but I would like to answer a little bit the question from Shankar and related to high risk and then philanthropy. And just as a data point, one data point, when I was president of Caltech, I realized very quickly, I didn't say it publicly, but when I woke up every day, my most important job was to find some resources to support the high-risk research. And I realized it was not going to come anymore, I'm sorry to say, from NSF or NIH or others, was to find a few people like Tom Siebel who are willing to do that, not the big foundations, by the way. And I think it's something your committee may want to think about, because the very out of the box high-risk stuff is getting harder and harder to support, I believe. And I support your opinion about large organization and large foundations. So it's not really a question, but I think something you should like to have.
One last question.
Hi, Bogdan Aprano from University of Michigan. My question is related really to the interface between multidisciplinarity and system thinking or science of systems. One of the important things is as modern engineered systems are ever more complicated, like the Internet of Things that Thomas mentioned or other engineered systems that David mentioned. So one of the questions is, how do you see the role of NSF centers in developing good science of integration or skills for students, both undergraduate, graduate, in using system integration in a more effective way? How do you see that helping you in terms of integrating complex systems?
So systems integration and systems engineering is something that we do a lot. And I think that the thing that we struggle with students coming in at the very start is understanding how to work in large teams and understanding how to communicate across disciplines. Those are the 2 key things that if these engineering and research centers could start to deal with, and safety, please. But if we could start to pull people in that already had the skill set to communicate across disciplines and to work in large teams and understand how to contribute to those large teams, I think that would be a really great outcome of the engineering research centers from my perspective of the people that we're hiring in.
I would just add, really emphasizing the importance of model-based approaches. and things related to formal methods where they're applicable. I really think there's an opportunity nationally to bring together what Tom was talking about in design, which thinks about empathy, thinks about repetition, prototyping, and so on, with physics-based models, so you don't have to do all those iterations. That's a part that hasn't been brought together yet, because if you think about the complexity of the systems we design, if I actually run a test and the results are better than I predicted, I actually wonder why. What was wrong with my model that I missed that, right? And so to have a culture, because when you think about supply chains and so on, where it's not having to iterate over and over again the test, but I can have things that I model properly from the beginning, understand that, because now I have so many different suppliers, I have to integrate that. And then also on these complex integrated systems, the use of formal methods to do things that are correct by construction from the beginning, rather than having to do trial and error to get there. I think these two trends, if that's embedded in how we think about all the different areas we work, the notion of platform-based design, of physics-based models integrated into our thinking, that will really help the transferability of the results.
I want to thank all the panelists for the. And now it's the turn of all of you to participate and contribute to the, and give us input for our committee of work and the discussion. And you all are divided into 6 different working groups where there will be questions related to the 4 questions you saw this morning to in the afternoon, and also some of what you heard. And on the back of your tag, you have whether you're in group 1, 2, 3, 4, or 5, or 6. And on the screen now are the rooms for where they are. And there are people to help you, but there's also a map in your folder. But essentially 101 and 103 are down this column here. And the second one, there's stairs that are going up. Each of the workout groups will be an hour long, and you'll have 2 questions to answer in each of those. They will be led by 2 committee members, and there'll be a rapporteur, and you're to try to come to some consensus, and you'll produce a poster, which everybody will be hung here, and everybody will get a chance to look at and to give consensus on things that they see and agree with. So I think it should be a fun time for everybody and very productive. So you can get a chance to walk, find your way, and you have essentially 6 minutes to get there.